So here's when I took this again, this course, I was told just use the smaller of the 2 degrees of freedom. Okay, which would be what in this case?
41.
41. That's not technically accurate. And I want to read this. I really like this in this book. This is in chapter 24. Okay.
Wait, what?
It says this. Okay.
Oh,
What are we missing? Only the degrees of freedom for the student's T model.
Yes,
Unfortunately, that formula is strange. The deep, dark secret is that the sampling model is not really student's T, but only something very close. The super secret trick is that by using a special adjusted degrees of freedom value, we can make it so close to the student's T model that nobody can tell the difference. The adjustment formula is straightforward, but it doesn't help your understanding much. So we leave it to a computer or a calculator. Okay? If you're curious and really want to see the formula, look in the footnote. Then I look down in the footnote, and it says, and you'll notice I'm reading here because this is not a formula I know or ever use. Here is the formula for the degrees of freedom for a 2-sample t-test. Please don't write this down. So then he gives you that formula, and then he says, aren't you sorry you looked? This formula usually doesn't give you a whole number. If you're using a table, you'll need a whole number, so round down. If you're using technology, it's even easier. The approximation formulas that your computer or calculator use can deal with fractional degrees of freedom, so it's okay to just deal with this way. So here's the thing, okay? You have to adjust this with a special formula here. This is not, if you want to know what the degrees of freedom are, hit calculate instead of draw. Is that money for me?
1% chance of seeing results. Oh, okay.
I don't even know. No, that's not this class. I don't know who that is. Okay. If you hit calculate instead of draw, go ahead. It will tell you the answer to this. And you'll see you get a lot more degrees of freedom than if you just use the smaller of the 2. How many do you get? 83 points. Okay, so you get like 83 degrees of freedom. It turns out, if you do it the way that I learned to do it, where I would have taken 41 degrees of freedom, I'm always taking fewer degrees of freedom than you're really entitled to. Okay, so you can do it the old-fashioned way too. Okay, you're just going to get slightly wider confidence intervals. It's slightly more difficult to reject the null hypothesis. But you might as well use 83 because that's technically right.
Okay. Cool.
What's that?
What kind of distribution actually is it?
No, that's 2 separate. Okay. All right, we're almost done here. Reject or fail to reject? Come on. Reject. You get to call on somebody to read a conclusion out loud. Come on, call on somebody. Let's go.
Alright.
Okay, if I assume.
Okay, so if I assume that there is no difference between, in how campus involvement affects non-returning and returning students. Oh, we're doing the first one. Okay. If I assume that there's no difference in how personal contact impacts returning and non-returning students, then I would only have a 0.0, I guess it's just a
Dude, I'd have almost no chance.
Yeah, I would have essentially no chance of seeing results as extreme as what I observed due to random chance. Therefore, I have enough evidence to reject the null hypothesis. And state that, that.
Just state it.
Okay, therefore, I have enough evidence to say that students who don't return to college have a lower mean personal contact level than students who do return.
Everyone agree with that? Don't use words like null hypothesis.
Okay.
I want you to just say what this means. Okay, so if I assume there's no difference, there's no chance of seeing these results. So my evidence is suggesting that there is a difference. Okay? Yeah? Okay, part B. What does part B say?
It's up to 98% confidence interval for the mean difference in campus involvement returning.
Okay, so that's the other one, right?
That's what I
The other numbers. Okay? Alright, you're done here. You did a very good job. Alright, let's go. Confidence interval. We've already checked assumptions. Okay? Estimate, plus or minus, critical value, standard error. What's the estimate here? What's the estimate? What am I looking for in notation? Right? X bar,
Sorry.
what are we gonna do? Non-returning minus X bar returning. What is that in our case? Negative 0.81? No, that was for those. We've switched it. What is it? 0.1 plus or minus critical value. Z star or T star? T star. You need a sure. You need a sure.
So much more.
Sure. How many degrees of freedom do we have? Do we say like, is there a line for 80?
Yeah, there's 80.
So there's no line for 85,
2.
but there's a line for 80. You never want to exceed your numbers of standard of degrees of freedom. Okay, try to always stay under what you have if you don't have a complete line for it. What confidence are we making?
98.
Is 98, is there a column for that? Oh, good. So what is it?
2.374.
2.374, is that what that says?
Yeah.
2.374. And do we know the formula for standard error here? S1 squared over what?
N1.
N1 plus S2 squared over N2. If you get this, this is all so easy. It's boring. We're doing the exact same thing.
It's because you've been doing it for like years.
What numbers are we having? What's S1?
Yeah.
No, that was over here. What's the same?
Like, there's so many other
1.03
things going on in my brain. I'm just like,
Yeah.
and
Like, it's not
1.01
really like.
yeah.
over what?
Wow, this is so easy.
No.
42 and 48. There's your formula. Type all that in, or stat tests, and find a two sample t interval.
My calculator is officially dead. Yeah.
All the oh no, we changed. You got to put all the new information. I want to do a paired one too, so let's do this quick. I mean, or you could just type those numbers in if you want. I'm not sure which is faster.
I'm really tired and hungry. I got this far.
What do we get? From what to what?
Is it 22? Is he collecting it? I don't know. I hope not, because
Negative point.
1.2.
To
So, like, when you're, like, interpreting it, you get, like, a Z
Okay.
square, right? No, sorry, what?
all right.
Stop your sentence.
yes, Carolyn, go. I'm 98% confident.
What did they say?
I am 98% confident that between negative 0.112 and 0.6112 of college students who are
You see, she's bungled it because she's gonna be in a place on this sentence where she can't finish it. You got to figure out what this means. Carolyn, what does negative 0.41 mean?
the lowest estimate.
Yeah, but what does it mean in terms of students? So it means that non-returning students are
less involved,
How much less?
41%.
Those aren't percents though, right? Because we're not doing proportions here. This is like an average, right? An average score. Correct? It's an average, what do they call it? The satisfaction score. Is that what they call it? What do they call it? The rating. Okay, let's just call it ratings. So this means that non-returning students have a average rating that's what?
Like 41 less than.
So we're 98% confident that the rating of non-returning students is somewhere between.
Like 41 less than 0.61.
Okay. Everyone getting that? Right? How we're
So
right? And this means if we did this over and over again, then what?
Then the actual value would lie somewhere between non-returning students have
Let's stop. If we did this over and over again, really got to get this by now. If we did this over and over again and made lots of intervals, 98% of our intervals would contain the true what here? The true difference, right? Not 98% of our intervals would be between
What's the
here. It's not
first
right. Okay.
I am 90%
So, looking at that, does
But the average
campus
non-returning
involvement
student has personal contact level that is somewhere between
seem to matter?
that the average non-returning student
Does it seem to matter?
or the average
We just
non-returning
said
student
that
has
Personal
a
contact
personal
matters,
contact
right?
level somewhere
But
between
campus
0.4112
involvement
and
doesn't seem to matter, right?
0.61.
It could be
One,
more or
two
less for
below.
non-returning students. Yeah? So, moral of the story, universities should focus on personal contact. Okay, not worry so much about campus involvement.
Can you actually just tell that? Because if you look at it you sort of like already have an idea.
Well, yeah, but you can't
Because
quantify
of
that,
the
right?
regrades
And so we do, what we're trying to do is quantify the difference. All right, that's two proportions t-test, excuse me, two sample t-tests. That's chapter 24. Now we're going to do chapter 25. Ready? I don't have a whole lot of time, but I'm going to give you some numbers. Ready? Okay, Mia, write these numbers on the board. Okay?
It's Friday too.
Okay, wait, so what I was asking you is like for the two sample
All right,
Z-test.
test,
this is about yogurt.
when you get like the Z-score, and then you
Okay,
get
are you
the
ready?
percentage from it.
Okay?
Yeah.
We want to know, is there a significant difference in calories between servings of strawberry and vanilla yogurt?
I thought you used the Z-score
Okay.
to like find your p-value, right?
Yes? So
And
what
then
they
the
have
p-value,
done
based on the p-value, reject or
is they
So,
have
based on like how do you reject it?
taken a bunch of yogurts
like if it's
and
low,
they
like
measured
there's
the
sometimes a
calories.
significance
Ready?
level or you
Here's
just,
the
like,
strawberry
tell
list.
them
Everyone
it's
else
low or
except
high.
Mia needs it on their
Like, if
calculator.
it's
Go.
not 10%.